Give the attendance in the chat. Okay, so let us go for the numerical. So the data is given like this. The useful torque of a three-phase 50 Hertz 8 poles induction motor is 190 Newton meter. So that is the torque shaft. Useful torque is nothing but the shaft torque is giving as 190 Newton meter. The rotor frequency is 1.5 Hertz. That is F dash is giving as 1.5 Hertz. Calculate the rotor copper loss. So PC is trying to find if mechanical losses are 700 watts. So this is the data what he has been giving. So now with respect to this, so we have to find what is the total copper loss. That is the rotor copper loss. Okay. So now with respect to this, so if I go for the formula in the presentation, can you able to see this presentation?
Yes, sir.
P2 is to
Yes,
PC
sir.
is to PM is 1 is to S is to 1 minus S. Okay. Now with respect to this, I'll take the ratio of PC by PM. Okay. So PC is the rotor copper loss, PM is the mechanical loss. So which will be equal to, so PC is S and PM is 1 minus S. So PC by PM will be equal to S divided by 1 minus S. So write down this formula. Have you noted? Have you noted?
One second, sir. One second, sir.
Now find what is the slip. So to find the slip, so we know the rotor frequency is 1.5. Okay. So supply frequency is 50 Hertz. So find what is the slip. So rotor frequency F dash is equal to slip times the supply frequency. So do you want me to type there anywhere? So rotor frequency, so FR is equal to S into the supply frequency. Okay. So slip we don't know. So FR is equal to 1.5, which is equal to S into T. So find S. What is the value of S? What is the value of S? Are you solving? Can you hear me?
Yes, sir. 1 second, sir. We're doing, sir.
Okay, fine. 1.5 divided by 50. So how much will be getting? Better here itself I can open my calculator.
3%, sir.
3%.
Okay, so 0.03 is the slip. So in terms of percentage, it is 3%. Fine. Next, once if you know the slip, so we require what is the next formula? That is PM is required. Okay, so that is S divided by 1 minus S you can find, that is we'll be getting the ratio PC by PM. But what is the mechanical loss? So I don't know mechanical loss. So to find the mechanical loss, so here one more formula is there. So which has to be represented as, so P output we have to find. So mechanical loss PM is equal to T into 2 pi N into 10 divided by 60. Okay. So here we have to find what is the shaft torque. So to find the shaft torque, we know shaft torque is 190 Newton meter. Substitute here, PM is equal to 190, but I don't know what is speed. Okay, so to find speed, again we know NS is equal to 120 F by P. The synchronous speed, NS is equal to 120 F by P. So find what is synchronous speed. So
1500,
120
sir.
frequency is 50, P is 8 poles. So almost we'll be getting around 120 into 50. So it is 1100 divided by 8. It is 750 RPM.
Yes, sir.
Okay. So next, once if you know NS, so you know the formula for slip. S is equal to NS minus N divided by NS. NS minus N divided by NS. So find what is N.
Sir, here we will take S is 0.03 or 3, sir.
0.03. If it is percentage, then again here you have to multiply by 100. If you are taking 3%. So always S will be in fraction.
Okay, sir.
So I think 720 or 730 RPM you'll be getting. Because 750 is synchronous speed. How much are you getting speed?
727, sir.
727.5 RPM. Okay, so now once if you know PM is equal to T shaft into omega. Into omega is equal to 2 pi N by 60. How much are you getting?
13K, sir. 13.7K.
Is power output.
PM, sir.
How much are you getting?
13.13706.
Okay, fine. I think that is the output power, I think. So it's not PM. It is output power.
Yes, sir. Yes, sir. Here, if you take 190, TSH is 190, then it is 14467, sir.
Output power is equal to 190 into 2 into pi is 3.14
Yes, sir.
into 727.5 divided by 60. How much are you getting?
14467, sir.
One, okay, 14.67 kilowatts.
14467, sir.
14 point,
467.
okay, 467 kilowatts. So this
Yes,
is the
sir.
output power, not the mechanical power. So this is the output power. Okay. So now output power will be equal to the P out will be equal to PM minus mechanical losses. So mechanical losses he has given as 700 watts. So find what is PM.
$15.16 kilowatts, sir.
Okay, 15.16 kilowatt. Everyone are getting these values. So now PC is equal to PM into S divided by 1 minus S. Substitute, find what is copper loss. So again, S is 0.03, not 3%.
$468.87, sir.
4?
$468.87.
Okay, so 468.87 watts. This is the copper loss which occurs when the useful torque is 190 with 8 poles and rotor frequency is 1.5 and mechanical loss is 700 watts. So this completes the first numerical. So second numerical, the full load power input. So shall we go for second numerical? Everyone have completed? Everyone completed first numerical?
Yes, sir. You carry on, sir.
Okay, so let us go for second numerical. The full load power input to 4 pole 50 hertz 3-phase induction motor is 50 kilowatts. So he is giving the input power as 50 kilowatts running at 1440 RPM. So actual speed is giving us N is equal to 1440 RPM. Calculate its full load efficiency. If stator loss are 1 kilowatt and friction losses are 650 watts. So this is the data he is giving. So note on the given data. So number of poles 4, frequency 50 hertz, input power 50 kilowatts, speed 1440 RPM, is telling to find the efficiency. If stator loss are 1 kilowatt and friction losses are 650 watts. So now with respect to this, if we go for the efficiency formula, so this is the net motor efficiency. So net motor efficiency is equal to output power divided by input power. So input we know it is 50 kilowatts. Okay. So we have to know what is the output power. So to find the output power, we have to find what is the shaft torque. Okay. So or we can go for the ratio. So that is PM by PC by PM is equal to S divided by 1 minus S. That is this relation. Okay, so here we can find what is the PC. So what is P2, what is PM. So everything we can find by using this formula. Okay, so now find what is synchronous speed. So synchronous speed is equal to 120 F by P.
So 1500, sir.
So 1500 RPM. So what is slip? S is equal to 1500 minus 1440 divided by 1500. So we will be getting around 4%, I think. Or 0.04 is the slip. Percentage slip will be 4%. I'll check whether we are getting 4%.
Yes, sir.
Okay. So now I'll go for the flow diagram. Okay. So we require the output here. Okay. So we know what is the synchronous speed. So to find the output, so here input he has given. So we have to find all this data. So stator losses he has given. Okay. So once the stator losses is given, so find what is the rotor input. So that is P2. So rotor input will be equal to P in minus stator loss. So we'll get P2. So to find output power, we have to find the middle values. That is P2. So PC is required, PM is required. Okay, input he has given as 50. So rotor input will be equal to the stator input, that is P in minus stator losses. How much are you getting? P2. So stator loss is given as 1 kilowatt. So 49 kilowatts is your P2. Stator output, which is equal to rotor input. Are you getting?
Sir, no, sir. Can you repeat once again, sir?
So we have to find the efficiency. The efficiency formula is output power by input power.
Yes, sir.
Right? So input power he has given already. So we require output. So if we want to find the output, so we require the middle data, that is P2, PC, PM. Everything is required with the losses. So now let us find what is P2. We know input power. So let us find what is the rotor input. So rotor input is P2. So rotor input is P2, which is equal to input power minus stator losses. So input power is 50 kilowatts. Stator losses given 1 kilowatt. So 50 minus 1 will be 49 kilowatts. So P2 is equal to 49 kilowatts. Got it?
Yes, sir.
Next, let us go for rotor copper loss. So to find rotor copper loss, again, so here we are going for the losses, that is P2 and PC. So P2 is 1 and PC is S. So P2 divided by PC will be equal to 1 divided by S. Got it?
Yes, sir.
So P2 by PC, which is equal to 1 by S. So you know P2. So P2 is equal to 49 kilowatts. We know slip is equal to 0.04. So find what is PC.
1960, sir.
How much?
1960.
Okay. So PC is equal to 1960 watts. So similarly, we know what is we can find what is PM. So we know PC, we know P2. Can you able to find PM? So same. So P2 by PM is equal to S divided by, 1 divided by 1 minus S. So find what is PM.
Four seven zero 47K, sir.
Okay. So
04.
47.04 kilowatts.
Yes, sir.
Okay. So that is the mechanical power. So now what is the output power? So output power will be equal to the mechanical power minus friction losses. So since friction loss he has given as 650 watts. So output power will be equal to PM minus friction loss. So PM is 47.04 minus 650.
46390.
Okay, so 46.39 kilowatts. So now we got the output. So find what is the efficiency.
%, sir.
Okay, 93%. Any fraction? 93 point some change or anything?
92.78.
Exactly 93 you are getting.
92.78, sir.
Okay, so 92.78 go right now. Only if it is 92.98 or 92.97, then you can run it as 93%. Otherwise, if it is less than 0.95, then you make it as whatever the value with fraction.
Okay. Okay, sir.
Okay, that is regarding second numerical. So let us go for the third numerical. A three-phase, 4 poles, 50 Hertz, star-connected induction motor running on full load. Before going that, is there any doubts with respect to first and second numericals? Only Jaipunit is solving, or what about others? What about others? So please try to solve. Okay, so let us go for the third numerical. A three-phase, 4-pole, 50 Hertz star-connected induction motor running on full load develops a useful torque, that is the shaft torque as 300 Newton meter. The EMF is completing 120 cycles per minute. If torque lost in friction is 50 Newton meter, so calculate slip, net output power, rotor copper loss, rotor efficiency, rotor resistance per phase if rotor current is 60 amps in running condition. So note on these details. So number of poles is giving us 4. Frequency is 50 Hertz. It's a star connected network. T shaft is giving us 300 Newton meter, and torque lost in friction. So it is not a friction loss. The torque lost, okay, torque lost in friction is 15 Newton meter. So we have to find what is slip. So directly, can you able to find? So what is the frequency is giving here? The EMF is completing 120 cycles per minute. What is that EMF is giving? So that is the rotor. Relating to rotor is giving. So 120 cycles per minute. So FR will be equal to 120 by 60. So rotor frequency will be equal to 120 by 60. We will be getting 2 Hertz. So that is FR. So rotor frequency is 2 Hertz. Then what will be the slip? So FR is equal to slip times the supply frequency.
4%.
Okay, so slip is equal to 4%. If it is in percentage, or it will be 0.04. Next, find what is the output power. So, or you can find what is the synchronous speed. Because for net output power, we require the shaft torque. So shaft torque already has given us 300 Newton. We require the speed. To find the speed, find what is synchronous speed. So 120 F by P.
1500.
How much?
1500.
So 1500 RPM is NS. So what is the value of N? So it is 1440 RPM. Because already we have solved the previous case. Are you getting N is equal to 1440?
Yes, sir.
Okay, now you know what is the actual speed of the rotor. So now find what is the output power. So output power is equal to TSH into 2 pi N by 60. That is the net
7536.
output. What you will be getting will be the net output.
7536, sir.
No. P output is equal to 300 into 2 pi. N is 1440.
Yes, sir. Yes, sir. 45.21.
Divided by 60.
45.238.
45 point?
238.
Yeah, kilowatts. So output power
Kilowatts.
is 45.238 kilowatts. That is the net output power. Now we have to find this rotor copper loss. So either we have to know what is P2, rotor input, or we have to know what is PM. That is the mechanical power. Okay. So find what is the friction loss. So he has given the friction torque lost in friction, that is TSH. TL he has given as 15 Newton meter, multiply with the angular velocity omega, that is 2 pi n by 60. So we will get what is the friction loss. Torque lost is 50. Find friction loss. Friction loss is equal to torque lost into 2 pi n by 60.
Yes, sir. That is.
So friction loss will be equal to how much?
7536, sir. This answer I told for the previous thing, sir.
How much are you getting? Friction loss.
7536.0.
Okay. So 7.5 kilowatts is the
Yes,
friction
sir.
loss. Okay. So now find what is the mechanical power. So output power is equal to mechanical power minus friction loss. The only thing, the power flow diagram you have to remember. And the last formula, P2 is to PC is to PM is to, which is equal to 1 is to S is to 1 minus S. So now P output is equal to PM minus mechanical loss. So find what is PM. So PM is equal to P output plus losses.
52.7 K.
Okay, 52.7 kilowatts is the mechanical power. So now you put that in the ratio. So PC by PM is equal to S divided by 1 minus S. So find what is the rotor copper loss.
Sir, is it
2198.75 watts.
Rotor copper loss.
2198.75 watts.
Okay. So that is the rotor copper loss. So that is the total rotor copper loss. Okay. So next, what is telling? Is telling to find the rotor efficiency. So to find the rotor efficiency, so we must know what is the rotor output and rotor input. So rotor input is P2. Okay. Again, we can go for the ratio. So P2 by PC, which is equal to 1 by S. So P2 is equal to PC divided by S. What is the rotor input? P2 by PC, which is equal to 1 by S as per the ratio. P2 is to PC is to PM, which will be equal to 1 is to S is to 1 minus S. So P2 by PC. So P2 is 1, PC is S. So P2 by PC is equal to 1 by S. So P2 is equal to PC by S. So you'll get input of the rotor. How much are you getting P2?
54.968 kilowatts.
Okay, so 54.9 kilowatts is the P2. That is the rotor input. So what is the rotor output? So rotor output is PM. I think already we have found what is PM. That is 52.7 kilowatts, right? So now find
Yes, sir.
what is the rotor efficiency. So rotor efficiency is equal to rotor output by rotor input, PM by P2.
95.99, sir.
95.99. Okay, so you can consider it as 96%. That is the rotor efficiency. Next, what is telling? So rotor resistance per phase, if rotor current is 60 amps in running condition, right? So now here we have to find what is the per phase resistance. Okay, so the rotor copper loss, what we have found, it is for 3 phase. So divide that by 3. So PC by 3, you'll be getting rotor copper loss per phase. If you divide that by 3, you'll be getting rotor copper loss per phase will be equal to PC by 3. How much you'll get?
733.0378.
Okay, so 733 is the rotor copper loss per phase. So now rotor copper loss will be equal to I2 square, that is I2R, rotor current square into R2, right? So now 733, which is equal to current he has given as 60 amps. So 60 square into R2. So find what is R2.
Point 2036 ohms.
0.2036
2036 ohms.
ohms per phase. It is ohms per phase.
Yes.
So these are the 3 numericals, and some more numericals I'll give the assignment. So later you can sit and you can try. And next numerical will be related to your equivalent circuit. Okay. So here, so we have to go for each and every formula. So I'll sit and I'll solve this, and later I'll go for dictating this numerical. Okay. So do you have any doubts with respect to these 3 numericals, what we have solved now?
No, sir.
Okay, so if you don't have any doubts, so we can discuss if there is any doubts.